Hey, so this is question 1.7 called rotate matrix. For this question, we're given an n by n matrix. So the number of rows matches the number of columns here. So there's like 4 rows and 4 columns. And what we want to do is rotate this matrix 90 degrees. And so that would look like this, where first it's 1, 2, 3, 4, but then it becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, kind of like this. So you're rotating it 90 degrees. Now for this problem, it's much easier to split it up into 2 steps. So first we're going to transpose this matrix. So where each row becomes a column. So the first row becomes the first column. The second row here becomes the second column, and so forth. And then after this, we're going to do another operation where we're swapping the first and then the last column, and then the second column and then the second last column, and so forth until you're getting into this kind of middle layer. So you can see here 1 and 4 swap to be 4 and 1, then 5 and 9 swap to be 9 and 5, and then it stops. So to do this, we first want to get the length of this matrix. It's matrix.length. Going to be using that a lot. So it's n by n, so we can just grab either the number of rows or the number of columns. We then want to use a temporary variable, and this will just be used to temporarily store our values when we're swapping them. And so to transpose it, what we're going to do is, because this is a 2D array, we're going to need 2 for loops. So and I equals 0, I is less than the length, I plus plus. Now, because we're dealing with an n by n matrix and we want to transpose it, what we're going to do is we're going to swap these values along this diagonal. So 1 and 2, 2 and 5 will swap, then 3 and 9 will swap, and so forth. So you can kind of see, 2 and 5 here swap, and then 9 and 3 here will swap. And so we're just kind of swapping these values along this diagonal. And so to do this, we have our second for loop in j, and we actually set it to I, and that's what allows us to increment it along this for loop, or along this diagonal. So when we're at 1 or at 0, we do along here and here, and here, get these values. And so that's how you're kind of going across the diagonal. And so then we do while j is less than the length, then j plus plus. And so here we want to set our temporary value to one of these. So do matrix I of j, and then we set the matrix j of, I of j equal to the matrix j of I. And then finally we set the matrix j of I equal to this temporary variable. And that's how you transpose it. So next what we're going to do is we want to swap these values across these columns. So 4 and 1 from here, 1 and 4, then 2 and 3 become, it would be these two. So 1 and 4 swap, and then 5 and 9 will swap. So to do this, we have a similar setup with another for loop. But here, what we want is, essentially we're going to have, I'll just clear out the body of this for loop, is we're going to have 2 pointers, because we want one pointing from this position and one pointing at this position for them to swap. And then we'll decrement inwards from this to this position, and then we'll increment this pointer to 9. So it's kind of the 2-pointer technique of swap these values. We decrement this one inwards, we increment this one, and then we swap these 2 values. So we'll have an int of j, we'll set that equal to 0, So that'll be the first pointer here. And then we'll have another pointer, which will be k, and that'll equal the length minus 1. So that'll be this last position. So then what we want to do is while j is less than the length divided by 2, so we're kind of meeting them towards the middle here. So because this one's decrementing until it meets the middle, and this one's incrementing until it meets the middle. And so next we do j plus plus and k minus minus. And so here we're kind of doing the same technique with this, just swapping these values. So temp I of j, and then we'll set I of j equal to I of k. Then we set this I of k equal to this temporary value. Great, and then at the end we just simply return this matrix. Oh, no, we just do this in place so we don't have to return anything. So if we just run this, I have just cd in my directory. There we go. And matrix.length, we don't have to calculate that since it's an array. And then boom, so that is our 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 9, 1, 2, 3, and then 4, 5, 6, 7. So that's how you do it. I hope it kind of clarified some things. The performance of this algorithm is O of n for time complexity. Now some people say O of n, some people say O n squared, so it's kind of O of n in terms of the size of this input. So it's a 2D array, so there's, it's n squared if you think of it in terms of the rows and columns, but it's really just constant time. It's in terms of, or not constant time, it's linear in terms of your input size. So, and then now the space complexity is O of 1. Since we're just doing this in place, we're just dealing with a void function. So great, I hope there, and good luck with the rest of your algorithms.